Okay, so it looks like we're here. We're going to go ahead and start. I want to share the video real quick on our micro-soldering group, our MacBook group I should say. Then we'll get started. So, I'm going to have a look and I will show you guys, see if we can figure this board out, because so the backstory on it is it does not turn on. I get it, and it turns on beautifully in boots. So they said that was not turning on for the longest time. It can't figure it out. I get it. Hit the power button, chimes. Starts normally. You know, I get my charger now. Let's see. So if I get my charger now, remember this was not working when it came here. It comes on my bench. We get a green light and a spinning fan, so it works, and it chimes. So let's go over and let's have a look. I'm gonna put my chat up here. So let's have a go over. Let's have a nice look at the board. You know, let's see if we could see anything. So, by our LVDS connector, notice that the marker is white. 1 second here, someone messaged me. Okay, so notice we don't have any liquid. It's just nasty, you know, it's just typical Apple nastiness. So, you know, I'll just keep looking. No signs of liquid yet, and if you notice, we did get a different microscope camera. It's still not the best, but let's go over and those probe points aren't actually coded. That's just how they look. BIOS area, another common cause of those issues. Looks beautiful. No issues there. JTAG connector. No, that's the trackpad connector. The JTAG's over here. JTAG looks. Wait a second. It's got a little green stuff growing on there, but that does not look that bad. I don't think that's going to be causing our issue. So let's keep going. Now I have seen ISLs cause a similar issue. I have seen ISLs. Boy, that's some beautiful Apple manufacturing, isn't it? I have seen ISLs cause issue where they quarter fan spin and holding the power button gets them to start. It's rare, but that does happen. So yeah, not really much. Let's look over here to the CPU MOSFETs. Looks pretty clean. Let's flip it over to the other side. Let's have a look at our ISL area and our 5-volt rail generation area. So here's our 5-volt rail generation area. Looks perfect. Let's move over to our ISL and looks perfectly fine. Imagine that. Continue. Now, what's one issue? Let's see if somebody in chat paying attention on 820-3332s. What is a common issue with these boards? What's a very common failure point? Perhaps U8900? But U8900 is going to cause video issues. U8900 is not going to cause random powering on, and those joints look okay. So let's have a look at our RTC area, since somebody said that. Let's check our RTC area. And on that board, this board, it's going to be right over here. I think, yeah, there's our RTC area. Looks perfectly fine. So, doesn't look like this board, you know, doesn't look like there's any liquid damage, right? Wonder what this is. Wonder what that resistor is, and wonder what that resistor does. This chip looks important. Let's see what that does on the board view. So let's go over and let's open a board view on a 820 3332. And U7400, what does this do? This does a lot of important stuff for the CPU. Okay, and what's this little guy look? CPU VID sys clock, S clock. Okay, quarter fan spin. Remember what our RTC does with quarter fan spin? Okay, very important right here. Now, why this works now after being shipped here, I don't know, but this looks important. So this probe point looks destroyed. We're going to go through and check now so we know what this does. This is our CPU buck converter IC, very important. Let's go through and just do a little testing on the circuit. Get our meter in diode mode. And let's test yeah, we're good there. This just needs just a little bit of rework here. So let's go ahead and get started. So this resistor's got to go. The one that's all nasty and corroded. We're gonna just put some flux down. As always, stuff on the end of my syringe. So, as always, put some flux down. Or hot air, and let's at least try and recondition some of those areas and see what actually needs to be replaced and where wires need to be run. I don't want to replace U7400. I don't have to. So hopefully I'm not going to have to replace U7400. These tweezers suck. I need a pair of tweezers. That's what you get when you're constantly scraping and doing other things that tweezers aren't meant for. I know I have my other pair, but I don't know where my other pair is. Alright, whatever. Just try and bend these back a little bit. One second here. There's quite a bit of corrosion on, you guys can't see that. There you go. There's quite a bit of corrosion on that one leg of the chip. Do I have no audio or something? No? Okay. So I see that little bit of corrosion. Let's have a look. I think we'll be able to fix that up. So next thing we got to restore. So let's say if you put a board in the ultrasonic cleaner with these probe points, it's just going to destroy it. You know, there's no. It's the colors on the microscope camera are a little bit different, but those probe points are destroyed. So what I'm going to do is just start cleaning up the area. I'm going to put a little alcohol down in a Q-tip. I'm going to move into my iron and flux and recondition this area. Just, you know, clean it up a little bit. Just a little bit of corrosion on this leg of the chip. Just see if we can get rid of it. Yeah, it's pretty corroded. Hopefully we don't have to replace this chip. Back to work? Yeah, back to work. No more missing a Doppler, at least for today. For the next few days. But, yeah, it's pretty corroded, but that's okay. We'll fix that. So what we're gonna do now is more flux and get our iron. I'm gonna go on a little bit of leaded solder at the pin of this chip, and we're gonna just resolder the legs of this chip, just like you would any QFN. So I'll show you how to do this. Get some solder on your iron. You know, move in. Just put a little bit. All right, you're just gonna, just like that. Just drag your iron along these pins. Don't bridge anything. I want your CPU to go pop. Get out of here. Notice you're gonna get some bridges, that's fine. Just a little more flux. I think my Amtech's expired, doesn't work as well. But, I mean, this tube is not that old. Turn my iron up, it doesn't feel right. Put like 840 like usual. That's better. At least it's not. Let's have a look now. Let's tilt the micro. Let's clean it up a little bit because that flux, not gonna be able to see it. And also, any customers are watching, any 820-3332s affected by the video issues, on any motherboard repair that comes in here, doesn't matter if it's unrelated, we are doing the U8900 fix on them. No additional charge, just part of the service. Let's have a look at what these pins look like. No bridges, they look decent. one on the end looks connected, I think. Yeah, it looks connected. So let's go ahead and move on to the next area of damage, and that's these probe points right here. They're not that bad, but what I'm gonna do, yeah, these aren't that bad. This one is corroded. You see the green. Now to recondition a probe point, quarter spin. It did have quarter spin, but the thing is, it had quarter spin. Then once it got here, it worked perfectly fine. So, recondition a probe point, simple. Just before, this is what I do before you get any nasty looking probe points. Before you ultrasonic it, do this. So, you know, sometimes you have to scrape a little bit because they won't take solder, but just clean them up with the iron and put a little bit of solder on them. That's gonna protect them for one, and they're not gonna get washed away. Sometimes they're gonna be completely so destroyed that you're not gonna be able to do that, but you know, just make a little solder blob like that. So I can do the same thing with this guy right here, and then this one, which is gonna be trickier because it's really corroded. I might have to run a wire. Run a wire? Yeah, I think so. Maybe not. Maybe we could get away with no wire. Yeah, no wire. Just kind of see where it looks a little sloppy right here. Do is just put your iron. Just clean up these joints like that. Never gonna look like you were here. So let's resolder our resistor right here. Go. And I want to try and touch up this pin. There we go. So I just touched up this other pin for CPU. Not CPU. Just the one that looked messed up. So that's reconditioned now. Looks good. I gotta find a resistor. What a lovely iron. It's a Hakko 951. It's a decent iron. So we have our donor board, has the resistor on it. We're going to go ahead and steel it. We're going to use a lower airflow. When you're taking resistors off donor boards, you do not want those to run away. It's the right board, it's 3332. Yeah, close enough. All these tweezers are lousy. Fume extractor, do your job. It's like not even. No, you don't run away from me. Nailed it. horrible. I think we're running a little too hot. I'm gonna lower it to 400. Good. The focus on your guys' camera is not very good. Let's see. Okay. So it looks good there. Just double check, make sure we don't have any bridges. This will get an ultrasonic bath. That one pin, we touched it up a little bit. It's good now. So yeah, we're good now. Let's just double check real quick. Actually, yeah, we're good. U8900. See if we can see any cracks in any of these joints. We're still going to put leaded solder down, just in case. Yeah, these don't look the best. Oh, and hey, look at this. We've got another little... Well, if water hit this area, then that's going to be expected. Yeah, you know what? We need to address that test point. So... This is for GPU. Oh yeah, that one was messed up. Yeah, having a good iron really counts, Leo. You don't want, if yours is one of the ones that has the heating element in the iron and you have to change it, the tips like sleeve over, save up for a new iron. I mean, it's such a big help. There you go. Alright, so U8900, we're going to also apply this fix while we're right here. This is done. Again, as a courtesy to all boards that come in here affected by this issue. Takes 2 seconds, and it saves the customer getting mad when their board has video issues. So just, and let it solder just like we did, right? Reflow these joints with some leaded solder. Nothing too, just like that, nothing, just like you would on any standard QFN package soldering it. So, what does everyone think of this new camera? I know it's not the best, but it's a little bit better than the AmScope camera that we had. I mean, it's not the greatest camera in the world, but it's better than having nothing. Hamdi, I am good. How about yourself? Got the radar working decently. Did something cool with the transmitter. We have 2 transmitters on one antenna now. Model camera is it? I don't know. Some Chinese 5 megapixel. It's good. So get ultrasonic. I don't think there's any other issues. We could look near the SMC. Oh, looks good. Just crumbs. Some green stuff on that test point. Nothing major. You know what? I'm gonna lift this up. I have to actually take this off because I don't know what's lurking under this thing. So, ugh, nasty. Look at this. Yeah, look at my hands after taking that off. Gloves. So, on top of that, this will get ultrasonic. Let's make sure it still turns on. That would be really lousy if it didn't turn on. I think it will. Green light. Now, the customer stated that they couldn't get it to power on here. I mean, they couldn't get it to power on. And for some reason this happens all the time, where stuff never works. It comes here, I do nothing and it works, but this board needed work, so it's gonna get, it's working. Test it multiple times. So now it's ultrasonic, and we're done. So on top of that, I think I've covered everything that I need to tonight. So hope you all enjoyed the video, and I will see you next time. Probably have some more radar stuff soon. I don't know. We'll see. Exciting stuff with the radar. Let me pull up a picture real quick. See, of our new the way I have the transmitter set up now. So instead of having just one transmitter, this is our display capture screen. What do I do? Come on. So what the goal of this is actually to increase the antenna gain. So you see we have two transmitters, right? So each of these are independent antennas, but we connect both transmitters. So both transmitters are outputting power to the same exact antenna. And that increases our gain and that increases our range. My goal with this is to increase the range as much as I can with as least amount of RF radiation. By the way, you said that it picked up also you're behind it or around it. You can shield it. I did shield it to only look forward. I actually in the enclosure I put lead. I used rubberized lead all in that, and it's still the transmitter still powered right through that. So, and we had some interesting results on using these cheap sensors to detect rain with the new antenna design. One sensor like that's not really going to do anything, but with this new antenna design plus a parabolic dish, I was able to detect rain clouds from what appeared to be about 20 miles away. I can't really, say that's set in stone yet, but okay, no cloud detected, right? Okay, and the only explanation was rain clouds that were about 10 to 20 miles away, so that's not bad with the new antenna design. It's only going to get better too, so yeah, but I definitely shielded that. There was rubberized lead in that enclosure, so it could only look forward, and it still sees from behind it. So it's I think it's more the frequency of the transmitting power, because they're only like 20 to 30 milliwatts each. So combine that on the same antenna, it's a little bit more. But so on top of that, I think I'm done. So I will see you next.